Hi, everyone. My name is Angie DeWalt, and I am a multi-cloud solution architect at VMware. Today, I'm going to be presenting VMware Cloud on AWS Networking Deep Dive. If you guys have any questions, feel free to, if you can, get off of mute. And if not, I will try to answer them at the end of the session. As far as what I'm going to go over today, I will talk about VMware Cloud on AWS just to introduce it for those who don't know what VMC is, then dive deep into the networking. So how customers can connect to it and the different types of connectivity. And then I'll talk about Transit Connect, which is used to connect multiple environments together for typically use cases that have either multiple AWS accounts or VMware accounts. So from a high level, what is VMware Cloud on AWS? So this is a jointly engineered solution by VMware and AWS that allows customers to accelerate their cloud migration in the lowest risk way. And what I mean by that is leveraging tools that they're already familiar with. This solution is delivered, supported, and sold by VMware. So for those who, again, are leveraging vSphere, vSAN, and NSX today, they're leveraging that same skill set. There are different cost analysis when we're looking at deploying this service. So you have your on-demand as well as flexible consumption. So for customers that are used to having the model where they're paying everything up front, there is 1 and 3 year options. And because this is a solution that is built in the cloud, the on-demand capacity is another option that customers have available. So they can provision the hosts instantly and pay for that on-demand capacity. When we're looking from left to right, customers will have their on-premise data center, and that can connect with VMware Cloud on AWS. So the actual service of VMC are AWS bare metal instances running in an AWS data center, and VMware will deploy that software stack on top of those bare metal instances or hosts. A benefit of this service is that you can then, because it's running on AWS bare metal, you can have communication between the VMC, which is VMware Cloud on AWS, and those AWS services, and you can start consuming those services quickly and rapidly, as they're all going to be running on the same AWS backbone. And that arrow that you can see between VMC and the AWS services, that is going to be called the ENI. So what this is it's a 25 gig connection between your VMC instances running and your AWS services. So you can have that connectivity to that AWS VPC in your VMC VPC. Just to give you a real world example, if that didn't make sense, let's say the customer wants to run a WordPress website. So they can spin up these bare metal instances in AWS, have vSphere, vSAN, and NSX running on top of it. They can have the WordPress website as a virtual machine, and that can be backed by an AWS RDS database. This is something that I have built before, and the benefit of this is that we have that communication between the ENI. So anything that's put into that database is going to be now backed by that RDS database, and that ENI has 25 gigs of bandwidth. And not to mention that communication is free between going from AWS to VMC. A few use cases that we typically see with VMC is DR, data center extension, cloud migration, and next generation apps. The two that I would say I see the most would be data center extension. So for customers that it takes a long time to procure hardware, or they need compute, they need storage immediately, they can spin up this VMC cluster of nodes, and it takes about 90 minutes to provision an SDDC, but as you add hosts on, as you add more capacity, it takes 10 to 15 minutes. So you're looking at a total, depending on how many hosts you want to provision, roughly around 2 hours to get compute and storage that you need versus procuring new hardware. There are supply chain issues, so that can take a long time to get a new server or a new storage array. So data center extension is one that we see a lot. The second would be cloud migrations. So for customers that want to run applications in the cloud, it could be native AWS applications, and customers that want to consolidate their on-prem data center. So they could have, let's say, 30 hosts within their data center. They're only using 50% of those resources. They're wanting to have less management as well as less resources to pay for since they're not using them. Then they can migrate those workloads to VMware Cloud on AWS. And again, this is a service that is supported by VMware. So VMware will monitor the underlying hardware and the underlying infrastructure. AWS will make sure it's running with the SLAs that they have, and the customer will be responsible for everything from the hypervisor level and up. So you're looking at provisioning the virtual machines, adding security on top of those virtual machines, and adding networking firewalls. So those are going to be the roles of the customer from this service. So VMware Cloud Components. As mentioned before, VMware will make sure that these services are up and running. So they will monitor the hosts, replace a host if a host fails, as well as have already provisioned the NSX and the vSAN. So that's already part of the service. The benefit of VMC, again, like I mentioned, is that let's say you have your system administrator who's used to running VMware. They could be used to running VMware 6.0, 7.0. You're able to allow them to continue managing the infrastructure the same way they are. The only difference is where that data is hosted or where those applications are hosted. And that will now be in AWS. So same software, vSphere, vSAN, and NSX. You have the capabilities of each of these. NSX is the networking virtualization service. So it has the capability to do layer 2 VPN, L2 stretch networks for customers that want to retain the IPs that they have on-prem when they move to the cloud. NSX has the ability to do that. You have Direct Connect for low latency, high bandwidth connections from your on-prem to your VMC environment. You can leverage NSX for that as well. From a security perspective, you have microsegmentation, which is essentially a firewall around an individual virtual machine. And then you have edge firewalls. So from north to south, when you're exiting the data center, you can have firewalls going in and out of your SDDC or your software-defined data center. When we look at how all of this is connected within that SDDC, kind of taking a broader step and looking at this from a broader angle, you have your VMware Cloud on AWS SDDC. So you can see here in the green box, it's the SDDC. This SDDC is going to be within an AWS region. So this could be US East, it could be US West. So you're looking at this as a bare metal instance sitting in Amazon with VMware software running on top of it in US East. So you as a customer can say, I want to go in and provision 3 nodes. So you can provision 3 instances, bare metal instances, and how those instances are going to connect to AWS and how you're going to have the connectivity throughout that SDDC is going to be in this manner. So you will have your on-premise data center is going to be represented in that purple box with the arrows in it. And that data center, that router is going to connect to an edge router that's going to sit within that SDDC. And that's going to be called the tier 0. So you can look at that as a north to south router, which is an edge router. You will also have 2 other routers. And when I say routers, it's more so in quotations because that's the functionality, but that's not what these are called, as you can see here. You have your compute gateway as well as your management gateway. So these are going to be essentially routers that have east to west communication. So when you provision your virtual machines, so within the service, you'll be able to have access to vCenter. And as a customer, you can go in and provision a virtual machine just like you typically would with vCenter. That virtual machine will be on that compute gateway, that tier 1 router that's in blue. And it will be on that segment, 192.168.1.0/24. Your management appliances, your vCenter, your NSX manager, those will be provisioned on the management gateway, which is another tier 1 router. And again, these routers have communication from east to west. As you can see at the bottom in the purple, the connected VPC, that's your ENI, that 25 gig connection into your AWS environment. And those will be your native AWS services running in that connected VPC. Okay, so let me see the question. Can you define firewall rules for specific VMs that are managed by AWS? So you can define specific firewall rules for the virtual machines that sit within this compute gateway. As far as the virtual machines managed by AWS, that's going to be within that AWS account that you have. So when you're looking at instances, like native AWS instances, those will be within this connected VPC, and this VPC is managed by the customer. What VMC does is it gives you that connectivity to the VPC. And again, that's free communication between your SDDC to that VPC, but the customer will manage this VPC. VMware will manage this VPC, which is essentially running, and they're both running in an AWS data center. But yes, the answer is yes, you can specify your firewall rules for the specific virtual machines that you have running. That's a capability of NSX, and it's called microsegmentation. So this picture just shows the ENI that's automatically created when you're starting up the service. From a process perspective, just so you all know, when you go into the VMC console, you specify how many hosts that you want to spin up. You specify the region where you want this SDDC to be in, and then you specify the connected VPC that you want to connect to this SDDC, and that's going to be customer managed. So in the background, a CloudFormation template or an automation script will automatically spin up these nodes, and it will connect that VPC that you specify to your SDDC. And so that's all going to be done in the background and automated. So as mentioned, the compute gateway, you can see that there are a bunch of virtual machines in there. The microsegmentation, so firewall policies apply to the specific virtual machines. You also have your edge router, which is going to be configured in active standby. So if this router does go down, there are 2 that are deployed. I've ran multiple tests. The failover is very quick, where it switches and essentially makes the standby router, which is just a virtual machine sitting in vCenter. It will kick that on, and then it will deploy another one in the background as the new one becomes active. And then you have your managed gateway for your management traffic, which will be your vCenter VM, NSX manager VM, and your ESXi host will be within that management gateway. Okay, so this is again more so of a high level overview of everything I just spoke about. So you have your ESXi host. So looking from the top down, when you're looking at the service, these are your bare metal instances. There are two types of instances that we can use for this service, i3 and i3en. The only difference between those two is that the i3en is built or geared toward more storage intensive workloads. So the i3en has about 40 terabytes of storage versus the i3 has about 10. So depending on the workloads that the customer needs, they can spin up however many nodes that they need to. And once you get to the full capacity of a cluster, then you can build another cluster. The edge, just to go over this one more time, it's for north and south traffic. So this can be connected to your other data center, your on-prem data center via Direct Connect. It can be connected via VPN to the internet. Depending on how you want that connectivity to your on-premise data center, the edge will be the method of communication between that external environment. This is what the SDDC user interface will look like. It's really just a simplified UI where you can access your primary network settings, such as adding segments, which are essentially which are VLANs. You can specify your NAT rules for your public IPs when you want the translation from your public to your private, and then your firewall configurations. I want to mention that you will have two consoles for management, I like to say. This console is your VMC console, your VMware.vmc.com. So you'll go in here, you can specify your segments that you want to create. So your VLANs, you can specify your NAT rules, you can add more tier 1 gateways for that east-west traffic and manage them. You have groups in here. So a lot of the administration piece of VMC is done in here from a networking perspective, troubleshooting, as you can see in maintenance. When you're looking at actually deploying the virtual machines, then there is another tab within this UI that says Open vCenter. So you can open vCenter, start actually deploying those virtual machines, your applications within vCenter like you typically would within your on-premise environment. So there are multiple ways to connect these environments together. Let's start, let me go back. So there are going to be two types of layer 3 IPsec VPNs that can be configured. There is policy-based VPN and route-based VPN. Either one of these can be configured over the internet, but if you want to configure a layer 3 VPN over Direct Connect, which is that dedicated connection, then you have to use route-based VPN. Policy-based VPN, how this works is it creates a tunnel using the IPsec protocol to secure the traffic, and then it will apply a policy to an interface, usually a uplink port on the VPN endpoint, and that will be connected to the SDDC NSX Edge 1 or tier 0 router. This VPN is not ideal for customers that are running multiple networks. Typically, when you see this deployed, it's for customers with small networks, because every single time you update your, let's say, segments, or you want to add more routes, you have to do this manually on both sides of the tunnel where you want to have your IPsec VPN. So it's really not a practical choice if you have a lot of networks, due to the fact that you have to continuously add these manual routes on both sides. So it is a viable option for customers that don't have a lot of routes, but typically in a production enterprise environment, they're going to leverage route-based routing or route-based VPN, which I'll talk about in the next slide. So route-based VPN, which I would say when customers choose VPN, this is the route they go 90% of the time. It can be over the internet or over AWS Direct Connect. The route-based VPN has a VTI or virtual tunnel interface, which you can see in green, and that's going to be created on the edge router. What that VTI will do is that it will establish a BGP session, and routes will be learned over those BGP sessions. The important part about this is that you won't have to manually add new routes every time you want to add a route to the VPN because of that BGP session. So due to that reason, due to the routes automatically being added, route-based VPN is the preferred way for VPN policies, especially when customers have a large number of routes that they want to communicate over VPN. Direct Connect is another way customers will connect their environments. This is going to be a dedicated direct connection between the on-prem data center and the AWS infrastructure or your SDDC. When you see DX, you see DX using public VIF and DX, that's just Direct Connect, that's the abbreviation. Direct Connect can be used with a public virtual interface or private virtual interface. Typically, we will see the private VIFs depending on the use case. From a public VIF perspective, public VIFs will provide connectivity to AWS public services or the public address space. So this connection will terminate on the AWS region, and how customers can connect to the services into this public address space is that AWS will advertise the entire AWS public subnets over BGP over Direct Connect. So that edge router will advertise, the edge router will receive all of those public address spaces, and then also the edge router will advertise all the networks in the SDDC. So there will be a lot of networks advertised if the customer decides to use public VIFs. And typically that's done if customers want to access the public services, let's say like S3, and not have it private, something that needs to be accessed over the internet and it could just be open to everyone. That's typically when a public VIF is needed. As far as the private VIFs, the private VIF is going to be used in most cases because, again, that's going to be an address space that is secure. The connection will terminate on the VPC level instead of the regional level. So like the public VIF will terminate at the regional level, as you can see in the picture. When you're looking at the private VIF, it terminates in the specific AWS region. So how the private VIF will work is the SDDC will advertise the routes over Direct Connect using BGP, and all outbound traffic from the ESXi host to the destination outside of the network, including vMotion, vSphere replication, that will be routed over the public VIF once it's set up. An alternative option for Direct Connect, if you want to use Direct Connect as well as VPN, is creating a route-based VPN as backup to the Direct Connect instead of just having Direct Connect. So we'll see customers have that route-based VPN as a secondary option in case their Direct Connect goes down. There are many topologies that we can create to make your Direct Connect resilient. It just depends on what the customer is trying to accomplish. I touched on the ENI a little bit earlier. but just to go over what specifically it is it's a virtual network interface that can be connected to instances running within the VPC. So that ENI will allow access to native services within the SDDC, and it's recommended to have the connected VPC in the same availability zone as your SDDC to avoid egress fees. So as you can see here, there is a AWS region in blue, and within that region, you have availability zones, which are clusters of data centers. So the way that that connectivity from that SDDC to your connected VPC is free is by having both of those running within the same availability zone. And this helps a lot with customers, especially when they want to consume native AWS services frequently with their on-prem applications, because that communication is free. The routing tables will automatically be updated for the connectivity between the SDDC and the connected VPC. As I mentioned, when you spin up the service initially, you have to specify that connected VPC, and that connectivity will be automatically inputted within those route tables and propagated within those route tables initially. Every time you add a segment, that will also be, if you're using route-based VPN or Direct Connect with BGP, those will automatically be updated, so the customer doesn't have to go in like with the policy-based VPN and manually add those. There are other ENIs that are provisioned within the service, but they are in standby mode. So if this ENI does go down, then an ENI connected to a different host will be brought up, and that connectivity will remain. So Transit Connect is a service that VMware came out with shortly after, having VMware Cloud on AWS, because the issue of how are we going to connect multiple environments to this SDDC? How are we going to have multiple SDDCs connect to each other that could be in different regions, or that are spun up because one SDDC has X amount of resources. So if the customer gets to that maximum, they have to spin up another one. So Transit Connect was created with a similar idea of Transit Gateway, which is a native AWS service. Transit Gateway has high gig connectivity. It's essentially a large router that connects multiple environments together. So just some examples of a native AWS Transit Gateway. It's like I said, a big router that can connect a VPC to a VPN connection. It can connect multiple VPCs together. It can connect within different regions, within different availability zones. So it's very powerful. It's a very powerful router and has a lot of capabilities to it. So looking from left to right, going through this diagram, Direct Connect is, again, that dedicated low bandwidth connectivity. Within your Direct Connect connection, you will have your gateway. That gateway can be connected to 3 transit gateways. That's the maximum. And then each Direct Connect can have 50 private or public VIFs. So these are just numbers that are good to know when you're looking at Direct Connect and Direct Connect gateways. So when you see that V transit gateway in the middle, that is essentially a VMware transit gateway. So it's going to be provisioned within your VMware console, but it has the same functionality or similar functionality as a transit gateway within AWS. So it's essentially a transit gateway. Again, there's less functionality, but it has the same concept as the native transit gateway. So when we're looking at that Direct Connect gateway, it's going to be connected to that virtual transit gateway. And like I mentioned before, with the issue that customers had is, how are we going to connect multiple SDDCs together? And that can be done through that virtual transit gateway or transit connect from VMware. And what that does is it allows virtual machines to communicate back and forth within two SDDCs. And then as you see number 3, that virtual transit gateway can now connect to 3 AWS VPCs and have connectivity to your VMware SDDC group. So this is huge because without Transit Connect, each of those AWS VPCs would have had to been connected via VPN. So instead of having 3 VPN sessions, now you can have that virtual transit gateway and have that central router for each of these VPCs. I do want to mention that when you're looking at number 3, that virtual transit gateway does not do transitive routing between those AWS VPCs on the right. You will have to have another transit gateway within the AWS environment, which would be like a number 4 over here, routing between these. So this virtual transit gateway handles the routing between this environment here, but it does not route between your AWS native AWS VPCs. The different types of topologies that can be leveraged with the virtual transit gateway are, and I think that was in my last slide, SDDC to SDDC, so to software-defined data centers, SDDC to native AWS VPCs, which is shown in this diagram, and then SDDC to on-premise via the Direct Connect gateway. So I'll show you guys all 3 of those. So SDDC to SDDC, this is what I kind of just went over. You have that virtual transit gateway. It's pretty straightforward to enable and turn on and provision within that VMC console. So this will allow any-to-any connectivity between the SDDCs. SDDCs must be in the same AWS region and in the same SDDC group. So when you're leveraging the virtual transit gateway, it does have to be in the same region. It is on the roadmap to have SDDCs within different regions and grouping them together or having connectivity using that virtual transit gateway. You can also add your firewall policies for your compute and management gateways as needed. So for, let's say you have an application that has financials, and then you have application that has your administrative things. When you're allowing this communication between these two, you can still put in firewall rules to specify that you don't want this segment to access and have connectivity to another segment. So that's a question that customers typically ask is, how can we prevent communication for applications or even BUs that we don't want to communicate with each other? And that's something that you can provide even when you have SDDC groups. Another type of communication is SDDC to VPC. So VPCs have to be within the same region as the SDDCs. So that's another thing that you can see here. Within that first diagram I showed, those VPCs were in the same region. So when you have connectivity with this Transit Connect to these VPCs, you want to make sure they're in the same region for the service to be able to work properly. So you can have that communication between these SDDCs, virtual transit gateway, and then they will access the Amazon VPCs. If you wanted communication, let's say you had 5 or more, or even 2 or more VPCs on this side that you want to communicate with each other, Transit Gateway, native AWS Transit Gateway can provide that communication, and they also don't have to be in the same region. So Transit Gateway has the ability to allow those virtual machines to route with each other within different regions, or allow those VPCs to route with each other within different regions. This, I would say, is the most common use case when we're looking at topologies. This one is leveraged, I would say, the most from SDDC to on-prem. The other two use cases I mentioned, those are for very large customers that need multiple SDDCs in different regions. Or multiple SDDCs because there's not enough resources within that cluster. This use case is very typical. So from left to right, you see we have the on-premise data center connected to Direct Connect. Just to mention it again, the Direct Connect has 50 public or private VIFs that you can provision off of this Direct Connect, and you can connect your Direct Connect gateway to it. This Direct Connect gateway has 3 interfaces that you can provision transit gateways off of. I mentioned that this is a transit gateway that's essentially managed by VMware. So this is one. So this would be one of the Direct Connect attachments to a transit gateway. So when we're looking at this, you can only provision another transit gateway off of this or another transit connect. So you can only have 2 more transit gateways attached to this Direct Connect gateway. So that's something that customers have to keep in mind as you start using these transit gateways. Know the limits because they can be reached quickly if you don't have someone architecting it the proper way. So then you have your virtual transit gateway, and the same thing, you have your edge router, which is your north-south traffic. So your traffic coming in will traverse through the Direct Connect gateway, go through that virtual transit gateway through the edge, which is your north-south routing, and then it will most likely go to your compute gateways for the virtual machine sitting on this segment. And then same thing when you're traversing out, it goes the same path. And from the management perspective, and it's on both of these, but your ESXi host, your vCenter, your NSX manager, those will all be within the management segment. VMware does lock down some of the permissions because this is a service, and so to keep the integrity of the infrastructure, there are some things that customers don't have access to. One of those things is root access to the underlying hosts. If you need to make changes to that, which I have never seen a use case where a customer needs to, but if there's things specifically needed, then you would have to create a VMware ticket or open a support if you need something changed. And then the management gateway, so you won't have access to some of those management components, which are going to be VM sitting on that management gateway. You'll be able to see them, but you won't be able to do much with them because it is a service and they want to maintain the integrity and make sure that the service is up and running at all times to be able to keep those SLAs and maintain them. So the last slide I have, and I'm happy to answer any questions outside of this, is the SDDC to on-premise. This is another design that customers can have. So as mentioned before, when you're looking at your Direct Connect connection, sometimes customers have already leveraged or already used 3 transit gateways. So the best thing to do in that instance is to start provisioning private VIFs, which are private connectivity into your SDDCs. So here you can see that there have been private VIFs that are provisioned off of this Direct Connect. You can have up to 50 of these, and these are connected directly to the SDDCs. So this gives customers that are on-prem that have exhausted, let's say, the Direct Connect gateway. They don't have any more transit VIF interfaces that they can provision off of it. So they start just provisioning these private VIFs on the Direct Connect, directly off the Direct Connect. This topology also still has another method of entering the AWS environment and having connectivity to those VPCs via this virtual transit gateway. Again, these are within the same region, so these are most likely within the same region as well. So you can still have communication here. accessing your AWS VPCs. So this could be native AWS services running within those. However, when you're looking at the separation within this topology, these VPCs don't have access to on-prem. So it just depends on what the customer is looking for, what they're trying to accomplish. There can be various networking topologies that can be created to address that specific use case. So with that, I am done. And if anyone has any questions, please feel free to ask, or if you ever have any AWS VMC questions, I'm happy to answer them offline if they come up later on. But I do want to thank each of you for allowing me to present today and listening to me, and I'm glad I was able to present to each of you.
Angie, Julia is asking if the slide deck will be made available afterwards.
Yes, could I provide that to you? I don't know who I can give that to, but absolutely.
Yeah, you can give email it to me, and then I can share it with the community. This will also be uploaded on YouTube, so I can include a link in YouTube as well.
Okay, fantastic.
All right, in that case, thank you everyone for joining us, and thank you, Angie, for the presentation.
Yep, absolutely. You guys have a great one. Take care. Bye.